Okay, so let's go over the saponification of an ester. We'll bring in a really simple ester. And when we treat it with base, we have hydroxide. And this reaction is driven by the strength of the nucleophile. So the hydroxide adds right on into the carbonyl carbon, and we push out onto oxygen like you're used to. So we have a tetrahedral intermediate. The O- can push back in, reform the carbonyl, and can kick out the OR side group under these basic conditions. And when we do that, the product that's formed is a carboxylic acid, and then the alkoxide. And just as soon as that's formed, there's an instant reaction between the carboxylic acid and either the alkoxide or another molecule of hydroxide. And remember, that's in great excess, so it's probably more likely, where the hydroxide immediately deprotonates the carboxylic acid. It's a very favorable reaction. And we make the carboxylate, which is exceptionally stable. And all of these things sit here. I'll bring back the alkoxide until you, as a chemist, go in and add acid. So I'll put a 2 to indicate, oops, that's a 2. That acid is not there until the end. And there's plenty of it. So both the carboxylate picks up a proton and the alkoxide grabs a proton. And in the end, what you have is carboxylic acid and the ester side iron alcohol.